All right, so on page 3 yesterday, I had you guys try a couple more, hopefully, of the point slope form problems. I think we did number 4 too, but just kind of working them through quickly and talking about them, and then I'll review some of everything today. Ultimately, your goal today is to feel confident on graphing all forms of linear equations. So I'm giving you a bunch of time to work. Number 3, I forget which ones we left off on yesterday, so I think we did 3 and 4. So I'll put up 5 and 6. So y minus the y coordinate would end up being y plus 6 equals my slope times the quantity x minus my x coordinate, so x minus 7. Number 6, you should have y minus the y coordinate of 2 equals the slope negative 3/4 times x minus the x coordinate, so minus negative 8 would turn into plus 8. We'll spend more time next week on writing equations, so the bottom half of these notes, we'll do more of those next week. So today is mostly the graphing. So especially you trying 9 and 10 and making sure that you can graph your point slope form pretty confidently. These are the ones we're more worried about for what we're working on today. So in number 9, your point from after a minus sign. So if there's not a minus sign here, you're pretending it's the plus sign is minus negative. So your ordered pair is negative 6, comma, positive 1 for your starting point. So over negative 1, 2, 3, 4, 5, 6, up 1 to start. And then from there, you're using the slope, which they have 3, to have a vertical and horizontal change of 3 over 1. So vertical change of 3, horizontal change of 1. If I have my point there, my line's going to be going up to the right. So there's my positive sloped line. Evan, can you get the door? You got it. Thank you. All right. 10, my ordered pair, my x coordinate would be 3, positive 3. My y coordinate from after that minus negative, if I pretended that was there, would be a negative 4. So over 1, 2, 3, down negative 1, 2, 3, 4 would be my starting point. And then my slope is negative 5 over 2. So I need a vertical change of 5 and a horizontal change of 2, and I need a negative sloped line. So I'm already picturing that it's going to be going down to the right. So vertical change 1, 2, 3, 4, 5. Horizontal change of 2 going this way, so that my slope is negative going down to the right. I'll do one more of those in the review today too, so if you're looking at that and you're still kind of like, okay, I'm not sure if I've got that down perfectly, we'll do some of each type in the notes. All right, I want to flip back to where we were writing some things yesterday based on our 3 types of linear equations. Our goal leaving class today should be that you can graph in slope-intercept form, standard form, and point slope form. So you need to be able to look at the equation, know which of the 3 types it is, and which 2 pieces of information are given to you in order to graph. So if you see something in slope-intercept form, because you have y equals, then you're pulling out the y-intercept and the slope and using those 2 things to graph. If you have something in standard form, meaning that the x and the y are on the right side of the equation, you're plugging in 0 to get the x and y intercepts. On point slope form, if it's in that form, you'll see the parentheses, so it's kind of more obvious, but you'll pull out the 2 pieces of information with your point and your slope and graph those. Oh, and that reminds me, I gave you guys a couple standard form ones to try. I'll pop back to that in a second. I forgot about these 3. I'll go through these quick. I'm not showing all of my work. I'm doing it in the way that you will hopefully be doing eventually, but I'm just going to sketch these out and say it out loud. If I plug in 0 for y and I divide by 5, my x-intercept is 1. If I plug in 0 for x, my y is already by itself, so my y-intercept would be 5. So that would be the sketch of that line. Number 11, if I plug in 0 for y, that would cancel out. Therefore, my x-intercept is 4. If I plug in 0 for x and I divide to get y by itself, my y-intercept would be -2. So there's the quick sketch of that line. And then number 12, if I plug in 0 for y and I divide by 3, my x-intercept would be -2. And if I plug in 0 for x, that cancels out. Divide by -2 would be a y-intercept of +3. I'll show my work one more time completely from what we did yesterday, but really if you're to the point that you can do this without showing any work, then your work today is just your graphs. You don't have to show work. The graph is your answer and your work. All right, one other little thing that I wanted to add to just kind of our list of different types of linear equations. You guys have 2 special case ones. So I'm just going to kind of title these my special case lines. You do know them from Unit 3, so if you got them right on the test, then we're in a good spot. But your 2 special case lines are when you don't have an x and a y in the equation. You're dealing with your vertical and horizontal lines. So just to put a quick sketch, because I kind of like that this page has all of the different types that we're running into. I just want to sketch one of these out of each, and then I'll do one more in our graphing review. So let's say the equation is x equals -3. That means on the x-axis, I have a line going through x at -3. When we did it in Unit 3, we talked about how the x-coordinate is always -3. So we could picture a bunch of points. Over -3 up 2, over -3 down 5, over -3 up 5, etc. X equals lines are always vertical through that point on the x-axis. So on the x-axis at -3, vertical through that point. In the last unit, when we had something like y equals 2, we should be on the y-axis at +2. Some of you already know where that line is. Otherwise, if we think that our y-coordinate is always 3, and if we just picture over 2 up 3, over 5 up 3, over -3 up 3, kind of reminds me that it's going to be a horizontal line through that point. So when you see a linear equation, if there's a y and an x, it's one of these 3 forms that we spent more time on yesterday, but I'll do another one of each. If there's only a y or only an x, you're dealing with a vertical or horizontal line. All right, turn to page 4. Page 4, 5, 6, and 7 has a whole bunch of graphing review. We're not going to do all of it. But you guys are looking at what type of linear equation is represented and how do you graph it based on the information that you have. So I'm going to do one more of each, and then I'm going to give you time to work. I have the answer key posted. I also have a hard copy if you want to check, and then you are just working and checking it. Your goal today before your really long weekend is to walk out of this room being like, I know how to graph all linear equations, because that's something that you should be able to say if you're in high school Algebra 1. Next week, we are focusing more on writing different equations. So today is the graphing, next week is the writing. So number 1, because y is by itself, I should look at this equation and know that it's in slope-intercept form. It's in the form y equals mx plus b. I'm writing down a couple notes. I suggest you do the same, but if you feel like you're catching on really quick, you can go ahead, but you have plenty of time today to work. When you're in slope-intercept form, the first thing you need to look at, and since these are notes, I'm going to put a little 1 by it, the first thing you need to look at and graph is that y-intercept. Since this equation ends with a -5 or a -5, that means that this line crosses my y-axis at -5. So you have to graph that first because that's your starting point. Then step 2, and again, I'm labeling it, but step 2 is to use your slope from your slope-intercept form. So my slope is 2/5. So that's a vertical change of 2 and a horizontal change of 5. I know my line's going up to the right because it has a positive slope. So I need a vertical change of 2 and a horizontal change 1, 2, 3, 4, 5 before I get that second point. And before I draw my line, I just kind of trace and make sure that my line's going up because of that positive slope. So vertical change of 2, horizontal change of 5, there's my line. So when you have slope-intercept form, first the y-intercept gets graphed, then the slope gets used. Number 2, I would call this one of the special case lines because what's it missing? An x. So if I just have a y, it has to be one of those special case lines. So quick sketching at this point, since you guys are done with Unit 3, should be I'm on the y-axis at -1, and then you're thinking, am I drawing a horizontal line through that point or vertical? Horizontal or vertical? Horizontal. And again, if you're not sure, then you think of more ordered pairs that have a y of -1, over 2 down -1, over -4 down -1, and I would see that horizontal line. Number 3 is in standard form. It's in that ax plus by equals c form. Standard form are the ones that I need the x and y intercepts. I get the x and y intercepts by plugging in 0. If you caught on well yesterday, maybe you're showing no work. Maybe you're showing a little bit of work. Maybe you're showing a lot of work for now and then slowly you're showing less. So I'm showing it like I showed yesterday. You guys pick if you don't need this, but I'm showing some work for this one. So I'm going to do 2x minus 0, so first I'm plugging in 0 for the y, equals -4. I'm going to have that mini equation to solve. And then I'm also going to plug in 0 for x. So I'm going to do 2 times 0 minus y equals -4. So you're essentially solving for two things, your x-intercept and your y-intercept. You get them by plugging in 0 for y in the equation and then plugging in 0 for x in the equation. So you get your two answers. I'm just kind of showing that anything times 0 is 0. So wherever that's plugged in, it can just cancel out. So you just have one quick step to solve for the x-intercept. So I'm going to divide by 2. So my x-intercept is -2. And again, if you get to the point today where you're not showing any work, you're just going to graph that right on the graph. You're going to go on the x-axis, put a point at -2. My second part, anything times 0 is 0, so that cancels out. What number is in front of that y? Not just a 1, but a -1, so just be careful there. So I'm dividing by -1 to get y by itself, so my y-intercept is a +4. So I'm on my y-axis at +4, and that's how my standard form equations get sketched. So I don't have a slope. I have an x-intercept and a y-intercept. All right. Number 4, so like moving forward, as I set you guys free, I have a couple more to do, but you're going to look at one like number 4 and you're going to see that the x and the y are on the left side. Therefore, it's in that standard form. Therefore, you're plugging in 0 and finding your x and y intercepts. Number 5, you should be looking at number 5 and being like, oh, that's another one of those special case ones because I'm missing the y. So if I don't have one of the variables, it's a special case, either vertical or horizontal line. So on this, I should be able to go to the x-axis at -2, vertical or horizontal, vertical. So I draw my vertical line through that point. And again, if you need more points, then your x is always -2, over -2, up 3, over -2, down 4. So shortcut, just go to the x-axis at -2. If you're catching on that it's a vertical line, there's your sketch. All right, I'm going to do one more with you. I'm going to do number 7 at the bottom because that's the only one that I didn't do yet on this page. Number 7 you should be looking at and seeing that it's in that point slope form. When those parentheses jump out at you, you're dealing with that. So I'm going to write above it y minus y1 equals m times the quantity x minus x1, so that we're kind of looking at how it looked yesterday. You have 2 steps on these, just like you have 2 steps on the other ones. Slope-intercept form gives you the slope and y-intercept. Standard form, you plug in 0 and get the x and y-intercept. Point-slope form gives you a point and a slope. So first, I want the point. The point comes in the linear equation. That x1 coordinate is after a minus sign. So because I have x minus 5, that 5 is my x coordinate. It is not a negative 5. And then my y coordinate, same thing, comes from after that minus sign. So my y coordinate is a positive 3. So step 1, graph that point. So over on the x-axis 5, up 3 would be the ordered pair 5, 3. And then step 2, I use my slope. So my vertical change is 1, my horizontal change is 2, my line needs to be going down, so I'm picturing which way it's going to go so that I use the slope correctly. So vertical change of 1, horizontal change of 2, so if I go there, that would be my negative slope. All right. If you flip a couple pages, this like goes on forever. I have 2 whole pages front and back of all the graphing. I don't think we need to do 2 full pages front and back. Plus we want to save some for next week before our little mini summative quiz in case we need to practice more types. So you are doing 1 through 18. So the front page and the back page. I'm gonna leave my answer key out and it's posted in Google Classroom, so you have both.